Have you heard a lot about 5G? It promises lightning-fast speeds and the ability to connect everything, but what exactly is 5G? And how can it achieve such extraordinary feats? This video will unravel the secrets of the 5G network, from radio frequencies to a completely new network architecture. Let's start with the heart of 5G, radio frequency spectrum. 5G's speed comes from using different frequencies. 5G operates across three main frequency bands: low band, mid band, and high band, mmWave. Low band, sub-6 GHz, provides wide coverage and good wall penetration, but its speed is only slightly better than 4G. Mid-band strikes a balance between speed and coverage. This is the backbone of current 5G deployments. High band, mmWave, delivers incredibly fast speeds, up to gigabits. But its coverage is narrow and easily blocked. To achieve optimal speeds, 5G needs to flexibly combine all three bands depending on your location. So, how can 5G dramatically increase data speeds? The secret lies in two key technologies. First is massive MIMO, multiple input, multiple output. Instead of a few antennas, 5G base stations use 100. These antennas can transmit and receive multiple data streams simultaneously. This significantly boosts network capacity. Second is beamforming. A 5G base station can precisely direct radio waves instead of broadcasting signals aimlessly in all directions. It focuses signals directly to your device. This reduces interference, improves signal quality, and increases speed for each individual device. Another crucial aspect of 5G is network slicing. This is a unique capability of 5G. It allows carriers to slice a physical network into multiple virtual networks. Each network slice is optimized for a specific purpose, serving diverse needs. For example, one network slice could be for self-driving cars, requiring ultra-low latency and high reliability. Another slice might be for IoT, needing to connect millions of small devices with low bandwidth. This architecture makes 5G extremely flexible and efficient, meeting diverse user demands. So what about 5G's ultra-low latency? Why is it so important, and how does it achieve that? Latency is the time it takes for a signal to travel from your device to a server and back. 5G reduces latency to milliseconds. This is achieved through new core network technology and edge computing. The 5G core network is designed to be more streamlined, reducing the number of signal transmission nodes. Edge computing brings data processing servers closer to the user, right at the base stations. This shortens the distance signals must travel, thereby significantly reducing latency. Ultra-fast speeds, extremely low latency, and the ability to connect billions of devices. This ushers in a new era. 5G will fuel the development of self-driving cars, remote surgery, and more immersive, virtual, augmented reality. It also serves as the foundation for smart cities and fully automated factories in the future. 5G will connect everything and everyone in ways never before possible, creating a truly hyper-connected world. From seemingly simple cell towers to complex aerial networks, 5G is a technological marvel. Next time you download everything in a flash, remember the invisible waves working tirelessly behind the scenes. What superpower applications do you hope 5G will bring in the future? Share your thoughts in the comments below. And don't forget to like, subscribe to our channel, and hit the notification bell so you don't miss out on more fascinating videos.